Hey guys, welcome back. It is week 7 of the Automotive Weekly Waveform. If you're unsure what we're doing or you haven't watched the other videos, I'll put a link down to the playlist down below. There is a video every week. I perform a simple test on the vehicle with the scope, show you guys how to do the test, and then you can post your results in the Facebook group. I'll put a link to that down below as well. Now, we're not really analyzing the waveform. We're mostly capturing known good waveforms. Because we're just doing it on whichever vehicle comes in the shop that is easy to get the waveform on. Now, some guys are already used to using scopes and they are using vehicles that have a known problem, or they're creating a known problem and they're sharing that waveform with us as well. But if you don't have time to diagnose a known bad vehicle with the scope, if you're still learning, the best thing to do is check known good waveforms, and that way when you get a known bad, you can kind of see the difference between the two. It's hard to analyze a bad waveform if you don't know what a good waveform looks like. So last week we did Hall effect sensors, which are common on crankshafts and camshafts on the vehicle. But there's another type of sensor that's common as well, and that's the VR sensor, or the variable reluctance. And where the Hall effect sensor is an active sensor, it has a power, ground, and a signal wire. The VR sensor is a passive sensor. So there's 2 wires, and depending on how we scope those wires, depends on what we're going to see on the waveform. There's normally a positive and a negative, and that's it. And we can either hook up to the positive and negative on the sensor, or we can have one channel connected to the engine ground and the other channel connected to the positive of that sensor. To get our maximum amplitude off that sensor, we need to be connected straight to that sensor on its positive and negative. Not all scopes allow you to do that if you're scoping other sensors as well. Now, if you're only checking that one sensor and the service manual says to go across them, then that's what you're going to want to do. If you're scoping other sensors on the engine and you're using a multi-channel scope that has a shared ground, then we're going to use the positive side of that signal, and we're just going to keep in mind that the amplitude might be a little bit lower than normal. Now, the other thing we have to watch with this sensor is the amplitude, or the size of that waveform, is going to change as the engine speed changes. The velocity of that crankshaft trigger wheel or camshaft trigger wheel going across that sensor, the faster it goes, the higher the velocity, the larger the amplitude is of that waveform. Which means when we're cranking it, we may only see that waveform at like 1 volt or 2 volts, but once it's running, it may be sitting around 20 volts. If we rev it up, it may jump up to 50 volts. Now, a couple of the members mentioned the component test meter in the snap-on scope. So if you're using a snap-on scope, I'm going to run through that really quick, which is going to give you information about the sensor, the best place to test the sensor, and it's also going to set up the tool for you with a good base setting to start with. So if you're using the snap-on, on the main screen, we're going to go to guided component test. Now this is a 96 Toyota 4Runner. Almost selected Oldsmobiles, we don't want to test anything on those. We got 96, 4Runner, 3.4 liter engine. Hit OK. We're going to go to the engine system and CMP sensor, the camshaft position sensor. Now in here, it's going to give us some information. Component information. It's going to tell us, yeah, it's a 2-wire sensor. We have a CMP plus, which the Toyota terminology is a G. And then we have CMP minus, which is G negative. Now I'm not sure on this particular vehicle, without looking at the wiring diagram, if G negative is actually attached to a ground source. So camshaft position sensor, G plus G negative, consists of a coil and 1-tooth timing rotor located at the front of the engine, the right bank cam gear. The system uses one sensor. CMP signal is an alternating current waveform and is critical to ECM operation. CMP signal represents standard camshaft angle and is used by the ECM to determine ignition and injection timing in relationship to TDC. Because remember, I think we use this vehicle for our relative compression check. This is a waste fire system. It fires the spark plugs twice. If it doesn't have a reference for the cam sensor, the spark will be fairly close to where it needs to be, but our injection time may be off. If it didn't have a cam sensor, it probably couldn't do sequential fire injection. The best test location is the gray or the black, flip those around, the black or the gray CMP sensor connector located the right front side of the upper timing belt cover near the power steering pump. And that's where I figured we were going to be at, so I already hooked up my back probe or my piercing probes up to those wires. So let's go back. Now, if you have a vehicle that won't start, they have a cranking test. It's going to tell you what that signal should look like. And then from this screen, see on this test, it's telling us to hook up to plus and minus. You can click on view meter, and we can crank the engine over. Now, this vehicle starts and runs, so this may not be the best setup for me. Maybe I'm running, but I'm setting a camshaft position sensor code. Maybe it has a signal code, or signal high, signal low, or even if it's a correlation code and I want to verify that that cam sensor is functioning properly, then we're going to go over to the signature test. The frequency test is only going to tell us how often that signal is coming up. It may not tell us what that signal looks like, but we want to see the signature. We want to see what that actual squiggly line looks like. So the same test locations, and it says right here, as RPM change, frequency and min-max voltages will change. We're going to view the meter. I do need to hook up a set of test leads to this. Okay, so I have sort of a waveform on the tool. Now, does it look like what they show me? No, it's actually backwards. So my test leads are probably connected backwards on the sensor. Do a little switcheroo here on the scope. And now it looks a little more like what their example waveform is. But as we can see, I'm off the screen on this waveform. But maybe we just need to expand the meter. So up at the top, it shows the meter, and it shows like a box in a box, or a box with arrows on it. We're gonna hit that button. It's gonna make that meter bigger. Now that it's bigger, I can change the settings a little bit. Hit the button at the bottom so we can see our settings. And our scale is at 10 volts. Now, I mentioned that cranking, we might only have 1 volt, and running, we might have upwards towards 20 volts. Well, if I move this waveform down, we can see that we're peaking out at about 10 volts positive, 10 volts negative. So let me switch this to a 20 volt scale. And now we can see the whole waveform. Let me minimize those settings. Let's drop the meter back into the box here. Does that picture look like what the example waveform is? I can even move my trigger over here. Yeah, it looks very similar. So I would say this cam sensor is working properly. If you go through the information, it'll probably tell you what the expected voltage of that sensor is. Now, sometimes they don't give you a running voltage, they just give you a cranking voltage, because it has to have a certain amount of voltage minimum before the computer can read that signal. So now that we have a waveform with it connected to the cam sensor plus and minus, if we were using another channel, we can't have it connected this way, because we're not going to use that ground for that sensor as a ground for checking other stuff. So I flipped the wire, the yellow wire, my signal wire at the sensor, so we should read proper polarity. And then my ground lead, I'm just going to hook this onto the intake manifold. So we have a very similar signal. You know, looking at the screen here, let me maximize this one more time. Now before, weren't we closer to 10 volts? I should have saved that screen. I think we were, but we lost a little bit of amplitude, but our signal is looking pretty much the same. So why is it having us check it at that negative terminal? Well, it's so we can get the maximum amplitude, so we don't induce a bunch of noise from other stuff on the vehicle. Yeah, we have a little glitch right here before our rising edge. I'm seeing a little bit of noise. I don't think that was there previously when we were connected straight at the sensor. Now my guess would be that that G negative wire is grounded inside the computer and it's not a floating ground. Because on some vehicles, if we connect to plus and minus, everything's centered right on the zero, just like we are right now. We have a positive and negative voltage from the zero line. But some vehicles, trying to think, I think Ford does this. If we connect to plus and minus on the sensor, it's centered on the zero line. If we connect to the positive side of the sensor and put our other lead to ground, we'll be sitting, our zero line is now at 1 volt. They put a little bit of a bias voltage on it. You may see that change in your waveform. My Toyota didn't do it. I think some of the Fords will. Now, since we have a lot of Subaru guys in the group, A Subaru, as long as it's the EJ engine, it'll have a VR sensor for the crankshaft sensor and the camshaft sensor. So pretty easy to get to. I'm not sure if the 3-liter has a 2-wire sensor or not, but as long as it's a 2-wire sensor, the camshaft is on the driver's side timing cover, actually right behind the timing cover. The connector sits straight up by the oil fill, so it's easy to back probe that one. The crankshaft sensor is difficult to get to. It's located underneath the alternator. So if you're checking the crank sensor, you're probably going to end up checking it at the engine bulkhead connector, which is underneath the air intake at the back of the engine. So that's it for this week. Really, it's only a single channel required for this test, unless you're adding on other sensors as well. But even if you're using a U-scope and you're just checking signal integrity, making sure that that cam sensor is putting out a signal, you are good to go. That is it. If you guys have any questions, put them down below or post them up in the Facebook group. If you guys enjoyed this video, give it a thumbs up. If you want to see more videos like this, subscribe, click the bell. If you're not a member of the Facebook group, I'll put a link to that in the video description. Thanks for watching, and I'll see you next time.